Is there another mysterious planet between Mars and Jupiter? NASA has made an impossible discovery in our solar system that could prove just that. The idea that another planet exists somewhere in the asteroid belt between Mars and Jupiter is not new. Already in the 18th century, scientists found evidence of another planet that, from a purely mathematical point of view, should be located right there. What new evidence has NASA found now? And does this planet really exist? In the 18th century, German astronomers Johann Daniel Titius and Johann Bode developed a mathematical rule according to which there should be another planet between Mars and Jupiter. Today, this idea based on mathematical statistics is known as the Titius-Bode rule. The two astronomers measured the distances of the planets from the Sun and established a certain order. According to this rule, at the point where the asteroid belt is located, there should be another planet. In the 18th century, the publication of this theory led to an intense search for this missing planet. However, only one object was found, and scientists are still not entirely sure whether it is a planet or not. Ceres, with a diameter of about 940 kilometers. This small body in the asteroid belt is large enough to have an approximately round shape due to its gravity. But is this really the missing planet? Recent calculations say no. There must be, or at least have been, a much larger object in this position. New careful analyses of planetary orbits, also with the help of modern astronomy, have provided evidence that there is indeed a planet in the range between Mars and Jupiter. Since the discovery of the asteroid belt, there have been speculations about its true nature. The hundreds of thousands or millions of fragments present in this section could be the debris of a larger planet. It is interesting to think that the asteroid belt is actually a field of debris. Millions of objects roam here, probably bound by the gravitational attraction of Jupiter. And we can be glad that the largest planet in the solar system binds all these debris to itself, because otherwise they would fly through the solar system like dangerous projectiles. Objects in the asteroid belt range from tiny specks of dust to larger bodies like the dwarf planet Ceres. However, Ceres represents so far an exception. Most rocks are typical asteroids, with diameters ranging from a few meters to 1 kilometer and beyond. Asteroids are not typically round like Ceres, but rather irregular pieces. The evidence that these are not asteroids, but planetary fragments, first emerged when scientists examined the region in detail and made measurements. They noticed an apparently chaotic distribution and the large amount of material in this belt. Computer simulations have shown that the way the fragments are distributed suggests a possible catastrophe. But what could be strong enough to destroy an entire planet? Before examining possible answers to this question, let's take a moment to consider what opposes this idea. Many scientists are certain that so many rocks have accumulated in this region because Jupiter exerts immense gravitational attraction. This would mean that Jupiter has bound many loose objects to itself over time, which were once distributed throughout the solar system and did not form in this position. Analyses of the composition of various asteroids also indicate that these bodies have very different origins and formation histories. Many asteroids have complex and diverse chemical compositions, but a hypothetical planet of common origin would have left behind fragments of similar composition. Most asteroids are composed of mixtures of silicate rocks and metals, as well as organic substances, and some are at least partially made of ice. Gigantic collision in the cosmos. Was the asteroid belt once a planet? Can you even imagine what forces would be needed to destroy an entire planet and reduce it to fragments? A hypothetical unlucky planet could have been the victim of violent collisions, or unusual gravitational disturbances could be imagined that could shatter a planet. One conceivable scenario is a massive collision with another planet or with a very large asteroid. Such collisions were more frequent in the early solar system, when planet formation was still ongoing and space was filled with large amounts of protoplanetary material. Planets often still moved in the solar system on chaotic orbits and collisions were frequent. One theory suggests that this is exactly how our moon might have formed. It is presumed that a planet that no longer exists today collided with our Earth and in the impact, mass was ejected from the still young and hot Earth, later becoming the moon. So, could the fragments in the asteroid belt be the remains of this planet? We don't know. Nowadays, the origin story of our moon is increasingly being questioned. Some scientists believe that the moons of the solar system also formed as small planets and that some of them may be structures similar to dwarf planets, but they were bound to the gravitational attraction of the planets instead of orbiting the Sun on their own. Comparing sizes shows very well that the largest moons in the solar system, such as Titan or Europa, are more or less the same size as the largest dwarf planets, while there are small dwarf planets that are not much larger than average moons. In terms of composition and shape, it is almost impossible to draw a demarcation line between moon and dwarf planet. But let's return to our hypothetical destroyed planet. A direct hit by another large celestial body could literally shatter a planet. Computer simulations have shown that the kinetic energy of an impact can be sufficient to fragment an entire planetary body. Simulations also show that the debris could have ended up in the asteroid belt. Some could have been flung out of the solar system, and some could have ended up in the Sun. Another scenario that could reduce an entire planet to fragments is interaction with the gravity of a nearby very massive object. It could be another star passing through our system or a very large planet being torn from its orbit. These scenarios likely occurred in the history of our solar system. For example, there is evidence that Neptune was pushed into its outermost position from a closer orbit to the Sun. If an object the size of Neptune passes through the solar system, the pressure on the other planets can be so strong as to either dislodge them from their positions or crush them. A third theoretical scenario that could destroy an entire planet is the accumulation of dark matter in the core of a planet, which would destroy the planet from within. Are the asteroids the remnants of an incomplete planet? Let's look at another interesting theory. Recent calculations by NASA scientists have sought to show that these rocks between Mars and Jupiter are not fragments, but rather bricks of a planet that was never completed. According to this theory, from the existing mass, another planet should have formed. These numerous pieces are made up of primordial materials that once gathered in this place to actually form a planet. This idea roughly corresponds to the theory of 18th-century astronomers, Titius-Bode. The forces might not have been sufficient to merge the mass into a single body, and Jupiter might have been responsible for this, with its enormous mass exerting both a binding and strongly disintegrating influence on the asteroid belt. These disintegrating forces could have prevented the objects from merging into a larger body. However, research has shown that the total mass of the asteroid belt is less than 1,000th of Earth's mass. This evidence, however, does not necessarily contradict the theory, as the asteroids we see today could be only a fraction of their previous mass. Computer simulations have shown that part of the primordial mass could also have flown into the Sun. It is also possible that some or even all of the objects in the Kuiper belt are parts of an incomplete rocky planet. The Kuiper belt is located beyond Neptune and hosts several million other objects over a width of several 100,000 kilometers. Many scientists consider all these theories too speculative. They believe rather that all the asteroids, rocks, dust, and other objects in the asteroid belt are direct remnants of the formation of our solar system. But if this is true, how could an object like Ceres form in this location? And what exactly is Ceres? Is Ceres an asteroid or a planet? Who would have thought that Ceres, which is now officially classified as a dwarf planet, has only 1/6 of the mass of our Earth? This means that the mass of this mini-planet is even less than the total mass of all the other objects in the asteroid belt put together. In comparison, even the dwarf planet Pluto has only about 2/1000ths of Earth's mass. So, a small planet could have formed from the fragments of the asteroid belt. It remains to be asked why Ceres remained so small and did not accumulate more material to become a larger planet. Obviously, there would have been enough material available. Incidentally, this question also applies to the numerous dwarf planets of the Kuiper belt, which also remained rather small even though there would have been enough mass to form larger objects. Ceres is a truly unique case for its location. It is certainly the largest single body in the asteroid belt and was discovered on January 1, 1801, by the Italian astronomer Giuseppe Piazzi. Piazzi was searching for the missing planet and initially was not convinced that Ceres, which has a size of only 940 kilometers, was indeed a planet. Thanks to its size and mass, Ceres has sufficient gravity to have a round shape. This characteristic is typical of planets and led to Ceres being classified as a planet for a period after its discovery. Over time and with the discovery of other similar objects in the asteroid belt, Ceres was downgraded to the category of asteroid and subsequently, in 2006, reclassified as a dwarf planet. However, Ceres is the only dwarf planet in front of Neptune's orbit. Studies conducted by NASA's Dawn spacecraft, which orbited Ceres from 2015 to 2018, have even found evidence of water, organic materials, and perhaps even an underground ocean, suggesting that Ceres may have been geothermally active in the early solar system. Sign up now for the channel. There are many other interesting videos coming.